normal curve, 9.4. So these symbols, first of all, this means the mean. So that's at the center, right? Most values are at the center in a normal distribution. And then this symbol, the sigma you saw the other day, and that means standard deviation. Standard deviation. And so what this is saying is these numbers you want to memorize. So highlight circle 68, 95, 99.7. To actually derive these, to find the area under the curve, this is also called a Gaussian curve, and you would need calculus to find this kind of area under something with a curve on top. If they were just rectangles, you could just add up the area. But when it's a curve, you don't need to do that. This is called the empirical rule. And we're going to use it to figure out probabilities of something occurring. So 68% are within one standard deviation. So if you plus sigma or minus one standard deviation, you get those. And then 95% is within two standard deviations. 99.7 is within three standard deviations. And that gives you these numbers. So let's talk about how you get them. So 68% is between here and here. 95 here, and then 99.7 is all of that. So, by the way, what do you think is under the entire curve? We kind of talked about it. Yeah, good. So under this whole thing is 100%. So how are we where do these numbers 34 and 34 come from? Yes. I do not want you to have to memorize on a test like 0.15 and 2.35. All you need to memorize is these three numbers. And you can let's talk about how you find these. So this is just 68 divided by 2, right? This comes from 68 divided by 2. It's perfectly symmetric in this formula. Where does how do I get the 13.5? What do I do to get this?
95 minus 68.
Does everyone see that? It's geometry. If you take this whole area, 95, which is 2 standard deviations away, and you subtract 68, and then you cut it in half, that you'll get this little slice. And then how would you get this slice? It's kind of the same idea. You would take the 99.7 and subtract the 95 and divide by 2. And that's going to give you this 2.35. And then to get this last one, you would take 100 minus 99.7 over 2. So you're always building out the layers. And you could come up with this whole thing, and you could answer any question if you have it all broken down like this. So let's look at some problems on the other side. Okay. So the other way, so I know I told you X bar is the mean. That's true. There's another way of writing the mean, and it's called mu, that you'll also see. And don't worry about the difference right now. So we want to figure out if our data is in a normally distributed shape where the average is 30 and the standard deviation is 4, what's the probability a randomly picked number would be less than equal to 34? So this P right here means probability. So what you do is you always draw a picture. So if we draw this, and then let's put a big mark where our center is at 30. And then we're going to go out 1 standard deviation above and 1 standard deviation below. So this would be 34, and this would be 26. I just added 4 and subtracted 4. I'm using the standard deviation. And then I'm going to do my second standard deviation. I just add 4 again, so I get 38. Then I subtract 4 and I get 22. And we'll go 3 standard deviations out. So this is 42, and this is 18. And then we're going to just approximate the bell-shaped curve above it. So put your peak in the middle, and then just make, this is about 60% of the way down, but don't worry about being too precise. I'm just going to put these dots over the top and then make a curve. It does not need to be exact. So there we go. So we'll answer all three of these questions by looking at this picture. So what I want to know is what is the area under the curve less than equal to 34? So I'm trying to find this area, and I'll shade it in for you in blue. I want to find all this area to the left of 34 using the empirical rule. You only get to use the numbers 68, 95, or 99.7, or you can also use 50%, right? Because half the area it's divided into half. If it's perfectly symmetric, so half of it is 50%. So how can you use geometry to find this area? Yeah, Sana.
If you take 50%
Uh-huh.
from left of blue.
Okay, so does everyone see that this is half, 50%? That's always going to be true. From the middle, from the mean, above or below is half of the area. It's just geometry. You can see it visually. And then?
And then since the standard deviation of 1 is 68, you can divide 68 by 2 and you get 34 and add that to 50.
Perfect. So 84% of the area is shaded in blue. So this is 34 because it's half of 68. And you memorize 68. 68 divided by 2 is 34. And then you add the 50%. So let's do another one. Probability, the number is greater than equal to 18. So I want to use the same curve. So I'm going to erase the shaded part. Okay, so I'll do this in green or something. So I want to find the probability, I want to find the area. Probability and area are the same. All this area, this whole thing there, that's greater than equal to 18. There are different ways to do this, and I want you to do whatever makes sense to you, as long as you don't have to memorize more than 68, 95, and 99.7. So what do you think is the easiest way to figure out this little piece, Tyler?
Well, it's between both of the third standard deviation, so it's 99.7.
Okay, good. So we're 3 standard deviations away. So we use 99.7. And what do we do with the 99.7? Mm-hmm. Roxana, yeah?
Well, because you still have that 0.3%, I believe, that's above 42. You need there's the 0.3% that isn't covered. But
Okay, so how do you? So let's start with this. How do you know that that's 0.3%?
because it's 100 minus
Over 2, right? So let's just stop there and make sure that makes sense. So this is, so that's 0.3, but then you only want half, right? So this is actually 0.15%. Because, so let's make sure we understand this. There's always 100% under the whole thing. We know that within 3 standard deviations is 99.7. So if we subtract that, we get this little piece plus this little piece, but we only want half. So that gives us 0.15%, that little piece. So the area then of the green part is 100 minus 0.15, which makes sense that it would be this much. It's almost 100% because the shaded area looks like it's almost 100%. Okay, last one, between 30 and 38. This should be a little simpler. So I want between here and here. So I want this piece plus this piece. So what would I do there? So you know this is 34, right? And we can find this by doing 95 minus 68 over 2. That's 95 minus 68 over 2, which is 13.5. So you basically just add up 34 plus 13.5. And you get 47.5%, which looks like a little less than half. So it makes sense that would be it. Okay, so now let's do one application problem together, and then we'll let you try one on your own and see if you've got it. So a radar unit is used to measure speeds of cars on a motorway. The speeds are normally distributed with a mean of 90 kilometers an hour and a standard deviation of 10 kilometers an hour. What is the probability a car picked at random is traveling more than 100 kilometers an hour? So you make your you put your mean in the center so we can see a picture of 90. And then we're going to go one standard deviation out. The standard deviation is 10. So we go up to 100 and down to 80. And then you can just approximate your curve over the top. And so what we're interested in is greater than equal to 100. What's the probability that x is greater than equal to 100? So we're going from here and everything above. We want to find all that area. So what would we do? Well, why don't we just do 50% and then subtract this? It seems to be the easiest, right? Because 50% is all of that. So let's do 50%. And then let's just subtract this, which we know is just 68 over 2. So that's how you show work, and you would get there's the area is 16%, or probability is 16%.